Good morning. My name is Scott Taylor. I'm one of the co-founders, and I'm the CEO of LiTHOS. We're a publicly traded company now on the Canadian Securities Exchange, and we trade under the ticker symbol LITS. So now that everybody's read the disclaimer, I'm going to try and frame a problem for you. So how many people in the room have an electric vehicle? Just raise your hand. One person. Okay. So do you know where the lithium comes from that powers that? Okay, well, we'll show you. So this is an example from the Salar de Atacama. This is the largest lithium mine in the Western Hemisphere. It's located in Chile, and this produces about 150,000 metric tons of lithium carbonate equivalent. So to give you a sense, this is a high-resolution image that's taken high above, and it's about the same size as greater Las Vegas. And what happens is you've got a shallow, brackish reservoir that's basically salty water that's about 20 times more salty than seawater, and it's got lithium enrichment inside of it. And the conventional approach that's being adopted right now is to pump that water to surface into these evaporation ponds. As we go from north to south, what we're trying to do here is remove impurities and to concentrate that brine. So when you go down to the southern part of this plot, you can see it's more brown. That's a more concentrated lithium. Now, even worse, this is what the people who work at these mines, this is what their conditions are every single day. They're basically wearing hip waders, and what they're doing is they're injecting acids into the ponds to remove the magnesium and to remove sulfates. So the entire promise of the electrification of the transportation sector and having localized grid storage, in my opinion, is kind of a hypocrisy when you see how the way that this stuff is produced. This is an embarrassment to humanity. And the problem is only going to get worse. So if we look at what the demand is looking like, basically very much driven by the massive investments in electric vehicles and in grid storage, as we saw before with one of the previous presentations there about the duck curve that you see in California. We basically need about 10 times more supply. And right now, the United States has one producing mine, and that's in Nevada. It was grandfathered in with those evaporation ponds. So can you imagine the panic that we would have if the United States controlled 1% of the oil and gas business in the refining capacity? Well, that's basically where we're at right now. So China controls over 72% of the control of the production and the upgrading of these facilities. So if you look at this demand, and then we contextualize right now what each of these new mines do. From a land perspective, it destroys 2,500 acres of a footprint. It consumes 10 billion gallons of water. That's like the equivalent of standing at Niagara Falls and looking at water for 4 hours. That's like filling up the Empire State Building 3,000 times a year. It's completely unsustainable. That installation that I just showed you there will produce about 250,000 tons of CO2, and it takes anywhere from 9 months to 2 years to pump out the raw brine in the first pit and have it precipitate through to the final concentration phase. So it's a very, very inefficient process as well, because basically what we're doing is, step one, we've got our reservoir. Step two, we're pulling that up into these evaporation ponds. These are lined pits. Basically have a cake of about 2 feet of magnesium and other impurities at the bottom, but we're losing anywhere from 30 to 60% of the in situ resource. And it also contains a lot of impurities, so that we see in step 4 when we do the upgrading, or called the polishing, to get to that battery grade mineral, we're losing about another 30% of the resource. So it's inefficient, it's unsustainable, but there's a huge amount of demand. So someone's really got to bring in a new approach to this. If you look at the total addressable market right now, it's about $14 billion per year. So that's equivalent for the entire production of continental brines in the Western Hemisphere is approximately 350,000 tons per year. If you look at the growth projections out to 2035, we need an additional 3.3 million tons of lithium carbonate equivalent per year. And if you look at where we're focused on, the serviceable addressable market, and primarily in Chile and Argentina, where you've got existing production that is rapidly being upgraded, is about a $2 million market. And that market is specifically focused on working with the large customers who have a sense of urgency to eliminate those evaporation ponds. So what are we? We're a solutions provider. So right now, we said we're listed on the Canadian Securities Exchange. We're just having our annual general meeting tomorrow to approve an independent board. So we'll become a non-venture issuer. So we'll be uplisting in the next couple of months to the CBOE. And then we've got some interest from a couple of banks in Manhattan to bring us onto the NASDAQ in the middle of next year. So we're a Denver-based company. We've got an initial pilot processing facility here. We are a subsidiary holding company that holds the technology, won a $250,000 grant from the state of Colorado over the summer. And we had just recently also won a $1.3 million grant from the Department of Energy. Right now we've got 80 million shares out. Management owns over half of that. So it's a very management-focused company here. So what's our mission? Is to completely eliminate the use of these evaporation ponds. And the vision for the company is to become the trusted global standard for sustainable and economically efficient lithium resource development. So our solution is basically we took a technology from the oil and gas business. And so I started looking at this a couple years ago, and I was thinking to myself, what have we done on in the fracking industry that might be something of a mature technology that we could transpose into another vertical, so that we're not starting in a laboratory and sitting there and fiddling around with research and development for 10 years. And so what I landed on was a local company here in Denver, a private company that had 6 years and about $10 million invested to commercialize anywhere between 10 and 50,000 barrel per day systems that were modular, field ready. And basically what what this technology has been used for is to consume the produced water that comes post-factum after you've finished a hydraulic fracture stimulation. So you've got sand and other formation solids in there. You have chemicals, you have the slick water that was used in the stimulation, and then you have hydrocarbons. And so this technology, it's piped in directly from the wellheads and flows out that produced water, and it's able to separate out the solids, it's able to separate out the chemicals and recycle those. It's also able to strip out either the oil or gas hydrocarbons there and return those back to the operator. And then it's about 98% efficient in terms of recycling and balancing that brine water. And then it gets piped back out for beneficial reuse, out to the subsequent next battery of wells that are going to get stimulated. So what as I said, what we've got right now is a pilot laboratory scale system that's based here in Denver, Colorado, and we've started to take in brines from Arkansas, from Nevada, Texas, and down in Chile and Argentina. So the advantages of this technology here is, first off, we're the only company that's in this space that's really fixated on that left-hand side of the value chain to focus on the pretreatment and the elimination of the evaporation ponds. When we hear the term direct lithium extraction, it's a bit of a misnomer because all of the other companies that are out there have developed really good bespoke technologies, some type of absorption or ion exchange or membranes that are able to take a pre-treated brine and very rapidly upgrade it and very efficiently get it ready for polishing. So they're adding value in terms of efficiency, they're adding value in terms of the speed of the processing, and also but they're not eliminating those evaporation ponds. They're all still relying upon that. And so that's really the competitive strategy for LiTHOS, is to partner with large companies that have a really strong sense of urgency to get rid of those ponds. The other benefits that we can bring to the table, if you look at the average capital expenditure for every 25,000 tons of lithium carbonate equivalent, that evaporation pond setup costs around $95 million, and our CapEx for doing the similar type of installation is going to be between 40 and 50% less than that. We should be able to shave off between 20 and 30% lower operating expenditure, and that's because we use less chemicals. We have a pressurized, it's a electrochemical process, so it's primarily consumes electricity to be able to remove the impurities and to extract the lithium. And then we've got a significantly reduced physical footprint. So the examples I showed you there before of like those field units that are processing around 25,000 barrels per day, they would fit inside of this room. So a huge amount of benefits and a huge amount of promise. So there's a couple different business models, and that's really going to be driven by the size of the customer. So if we're dealing with a company that's very well established down in Chile, like LITS.CN, for example, we'll be selling and providing services to them. If we look at a more junior company, like another company that we're working with called Lexi, that's just drilled their first discovery well over in Argentina, what we'll do is we will take in their brines, generate a flow sheet, and then license that technology to them and take a royalty in the lithium production. So there's kind of two different business models depending upon the size and the maturity of the assets. So right now, we're focused for the rest of the year, head down. Really what we have to do is prove to the market that we can get a reliable output. And so it's a very simple binary set of tests where you've got an input fluid chemistry with a certain amount of impurities, and then you have to be able to show demonstrated performance that's either a pass or a fail of being able to remove that magnesium and remove those sulfides within a certain tolerance. And so we're doing that right now with LITHOS in Chile, so it's obviously the best reservoir in the entire planet. And then we're also focused down in Argentina. Now we're doing a test with Rio Tinto. In Nevada, we're working with 3PL, and then there's a couple large oil field companies in Arkansas that we're also working with. So these are sort of some of the key tractions and highlights that we've got as a company. So as I said before, we've won a couple of grants. We won about $1.55 million in non-dilutive funding from the state and the federal levels over the past couple months. We published our first U.S. patent in January of this year. We've got our pretreatment facility here in Denver that's online. And then we're looking to scale up a capacity to build a full, much more further down to the right of that value chain so that we can generate a lithium hydroxide monohydrate. And now we're looking at a facility out in Alabama. And the reason behind that is that there's no production capacity in the southern United States right now. And the most prospective reservoir that we have in the south right now is the Smackover. You've got Standard Lithium there that's partnered with Koch Technical Solutions. You've got ExxonMobil that recently made a large acquisition from Galvanic. And then you've got Tetra and Galvanic as well that have more exploration going on. So I would say that that's most likely going to be the first reservoir that will actually generate meaningful production from a brine here in the United States. Also, the advantage with Alabama and Arkansas is that the water rights for production from a salty, briny solution of something that's not oil and gas is very well defined, because that's actually where we have the largest boron facility with Lanxess that's been in operation for decades. So if you look at other states, like Nevada, Utah, Arizona, getting the water rights issues is something that's unfortunately it's not solved. So there's a bit of a hassle there. And as I have a chance to present and continue to grow the story, hopefully I can share with you a couple more details around these customer validation stories. So now I just open it up for some questions, and thank you all for your time and attention this morning.
Yeah, so if you have some questions for Scott, please raise your hand and Larry will get the microphone to you.
Thank you.
Thank you very much. That was very interesting. And I'm glad you're here in Denver, so we can talk to you later again. What happens to the water when you're pulling it off? What's the condition of the water? Is it potable, near potable? Is there reusage?
This is like, it's about 10 times more salty than seawater. So it's a non-potable water. You can't use this for agriculture. You can't use this to feed livestock. It would kill them. So you're basically, what you're doing is you're pulling out the raw brine, running it through this fancy filter, and then you're strategically re-injecting it to manage the pressure in the reservoir with this approach.
Can you describe some of the challenges that you faced as you were going through the development process in the laboratory and things maybe that you had to work through, and how the process is working today?
Yeah, so it's I think I'll answer it in this way, is if you look at the implementation of the actual flow sheet and the sequencing of these electropressurized membranes, the selection of the membranes, the selection of the electrochemical setup, the sequencing of the way that we're getting, removing the divalents and trying to keep a concentrated monovalent solution, it's unique to each reservoir. So for example, the flow sheet that we've implemented for Rio Tinto, for example, is completely different than the one that we're doing with SQM. So the real challenge is taking a detailed analysis of the chemical assays of that raw brine, looking at the constituent impurities, and then strategically working together with our technical team to implement the appropriate solution. That's basically what you're going to have to kind of think about, to do this more broadly. There's not a cookie cutter solution. Each one of those reservoirs has its own sort of unique fingerprint, and it's going to require its own sort of reconfiguration of the way that we've got our process patented. And so that's what we went after. We didn't patent, a specific technique. We patented the whole process in a way that we can reconfigure it with a multiplicity of different tools and techniques.
Very interesting. So particularly the mature oil and gas industry, we're really water producers with a little bit of oil as a byproduct.
Yep.
So have you started to build a database for things like mature water floods or other places where there's, or for example, North Dakota, where there's a significant amount of water production, for a database of what those brines may be available or capable of doing for you, for your process?
Yeah, so my partner Frederick was approached by natural gas partners to do just that, probably starting in 2017, 2018. I would say at this time, this is not our core focus to look at like production of lithium from oil field brines, just because the concentration is typically quite low. So if you think about what we've got in the Smackover, you've got sort of an average grade between like 300 and say 400 parts per million lithium in its raw form. If we look at some of the oil field brines where people are seeing like, I'd say like sub 100, you have to move, 4 or 5 times as much volume of water per unit production that you're able to extract out. So maybe in the future, when we've matured and we've optimized our process, then we'll start to explore those. But at this time, I just don't see that, because of the volumes of water that you have to handle, I don't think it's economically viable. And that may be just a limitation of our maturity as our company. So that's why we're kind of focusing on the most highest quality reservoirs where we think we can make an immediate impact. And then, start off with something that's easy and then work our way in the future towards like the more challenging reservoirs that we've got here.
One more quick question. Could you discuss, I guess, what makes you so special with respect to what is your IP, and talk a little bit about your technology?
Yeah, so it's a published patent. I can share it with you if you want to take a look at it, and we can do like a deeper dive. But I would say that the way that we approach it is combining a multiplicity of different techniques. So we've got membranes, we've got a fractionated electrodialysis stack, and then some absorption or ion exchange. And so the way that we've patented the process is that we can include or exclude any one of these different techniques that we've got available in a very specific sequence. I'd say the organizational experience in terms of having processed brines that have lithium enrichment and that are quite contaminated, going back to 2016 in each one of the major basins, has given us a really strong handle on impurity removal. And I think the other competitive advantage that we bring to the table is just, again, that organizational experience of having been able to demonstrate that we've got operable systems in the United States that have recycled for beneficial reuse this water, to remove impurities, remove contaminants, and I think that's really what's going to give us the time and attention of these target customers that we're starting to work with. But I'm not trying to be overly vague, but it's quite a complicated answer if I want to jump into details. So just come up and pass me your card, and I'll show you the patent and be happy to explain to you in greater detail. I think the best way that I have to do that is kind of contextualize the implementation of this process on 2 different reservoirs, because you're going to see it's a dramatically different flow sheet. It's not a one-size-fits-all type of solution.
Help me thank Scott with LiTHOS.
Thank you.